Imagine trying to cool down a room using nothing but a bucket of ice. As the ice melts, it pulls heat out of the air, making the room cooler. That's actually the same basic idea behind air conditioning. The problem is that melting ice works pretty slowly. To speed things up, you point a fan at the ice. More air moves across it, the ice melts faster, and the room cools down more quickly. But constantly replacing melted ice would be a huge inconvenience. So what if you could use a substance that cools itself over and over again? That's where refrigerant comes in. Under normal conditions, refrigerant exists as a gas. But when it's squeezed into a high-pressure container, it turns into a liquid. Next, you build a closed loop of copper tubing and fill it with that liquid refrigerant. As it enters the indoor section of the system, the pressure drops. The liquid instantly begins changing back into a gas, and during that process, it absorbs a large amount of heat from the room. That's what creates the cooling effect. Now you've got hot refrigerant gas moving through the system. Instead of letting it escape, you send it through a compressor. The compressor squeezes the gas, raising both its pressure and temperature. Since the gas is now extremely hot, it travels outside to a condenser coil. A fan blows air across the coil, carrying away the heat. As the refrigerant loses that heat, it changes back into a liquid, but it's still under high pressure. So before it can cool the room again, it passes through a tiny expansion valve. The pressure suddenly drops, causing the refrigerant to become much colder almost instantly. The chilled refrigerant flows back indoors, ready to absorb heat all over again. An indoor fan spreads the cool air throughout the room, while a temperature sensor monitors conditions and helps maintain the setting you choose. Separate the system into an indoor unit and an outdoor unit, and just like that, you've got a modern air conditioner.